Okay, hello, welcome to the walkthrough for our latest key assessment, so map 2, week going in 25th of the 11th 2024. So we'll go start with question 1, always a good place to start. And what we've got, the value of 7 squared. Now 7 squared is the same as 7 times 7, so 7 times 7 will give us 49. You don't need to put that bit, just explaining it as we go through. For question 2, we've got to work with decimals, okay? And the traditional thing is they put it in that format for us, which is no good for us. Rewrite it, and we'll split it into 2 parts. So first off, I'm going to do 5.22 plus 1.09. Okay, so 2 and 9 gives me 11, 0 and 1, and the 2, so we get 3, and then that will give me 6. So we've got 6.31. Now the temptation is now to do the next bit and just go minus 2.1, okay? Don't show it like that, treat it as a separate thing, okay? So we've got 6.31, we're going to take away 2.1. Now they're different lengths of numbers, so I'm going to pop a 0 there. Doesn't change anything, so that's still going to be 1, 1 from 3 is 2, and 2 from 6 gives us 4. So we end up with an answer of 4.21. 2 marks available, so 2 steps, okay? We want to see those steps each time. Now these next ones are slightly unusual for us in as much as they're actually telling us to measure, okay? Normally it's not drawn accurately and we don't trust the drawing, but this time we can, okay? So what I can do here, if I measure this, and we can see on our line, so from our 0 up to there, so we've got just under 4.5. Now that's under 4.5 centimeters. They want the answer in millimeters. So handily, I have got millimeters on the other side, and when I go up through there, I can see it actually comes to about 44. Okay, so I'm going to put 44 millimeters. If it had been in the centimeters, if your ruler only had the centimeters, we know that each of those individual lines is a millimeter, so it would have been just times it by 4. We'd have got our 44. Okay. Now we can't get rid of that drawing just yet, because the next question wants to know angle Y. Okay. And it's this angle here. Now, first thing I want to do when I'm dealing with an angle is I'm going to put a dot in the center of that there, okay? And the reason for that is it makes it easier to line up the crosshairs of my protractor, okay? So I've got that roughly set there, and the 0 is the 0 that lines up is the 0 on the inner scale. So I'm going to go up on this scale, and I can see that I've got between 50 and 60. Now, if it's difficult to read, just extend that line, okay? I've not changed the angle or anything, just extended it to make it easier for us. And now when I set that up, I can now see that it's above 55. So basically, I'm going to go with 57 on that one, okay? So I'm going to say that that one is 57 degrees. Now a quick check for both of those on our mark scheme, we can see there's a range there. So for the measurement, it was anything between 43 and 47, and on this one, anything between 54 and 58. Okay, so because we're measuring, they give us a little bit of leeway on that one. So our next one, it's an inequality. So there we know that it's greater than or less than, and if we remember it from school, the open end of the crocodile, the open mouth of the crocodile always goes to the biggest value. So that means 12.1 is greater than something. So all we need to do is put in any number less than 12.1. I'm going to go the easy route, I'm just going to put 12 because it's 0.1 less. That's the easy step, but we could have anything under that. Okay. So then we're on to number lines. And a common mistake here is to look at the lines and go, well, 1, 2, 3, 4, 5 lines, so it must be split into 5, and we can break it down that way. It's not. Go from each gap, we've gone 1, 2, 3, 4. So we've actually split, between 3 and 4 is split into 4 segments. So this middle one is going to be 3.5, which makes A 3.75, okay? And notice again, I always make my decimal points nice and big so they can see them clearly. Similar on this one, we've split it. This time we're looking for B, so we've split 1, 2, 3, 4, 5. And there's 100 difference between these two numbers. So 100 divided by 5, we know that each one of these blocks is another 20. So we've gone, we're in the negatives. So we've gone from negative 100 to 120, 140, 160 to 180. And it is a negative 180. If you put 180 and you've not put the negative, you will lose that mark. Okay. Moving on. Question 5. And we have a shape. Now it's a 6-sided shape. So it is a hexagon, but it's not a regular hexagon because these sides, the sides may be equal, but the angles aren't. Okay, so it's not a regular shape. So what we need to do for this question, rotational symmetry. If we rotate this shape 360 degrees, how many times does it appear as the same shape? So if I start turning that, I'm actually going to zoom out so we can turn it a lot easier. So as I turn that, it's not the same shape. As we keep coming round, so 180 degrees out, we've now got the same shape. And then we come back around to 360 degrees and we have the same shape again. Okay, so that means it has a rotational symmetry of 2. From its start point all the way back around to the end, it's only the same shape twice. Okay. There's nothing to stop you rotating your paper during an exam. They might look at you a bit strange, but it doesn't matter if you get the right marks. Let's face it, the invigilators don't know what you're doing. So then we're on to some algebra. I'm going to mix these up a little bit. So we're going to deal with 6a. We've got b plus b plus b. So basically, when we see a letter, we know there's one of those. So that's 1b plus 1b plus 1b. So we end up with three b's together. Okay, it's only adding, so there's 3 lots of b. No multipliers, no powers, nothing else involved. Okay, so I'm going to mix these two up. Multiply out and factorize because they are flip sides of the same thing. Okay, multiply out means we get rid of the brackets. And what we're doing is we're multiplying everything inside by what's outside. You can do the claw if you're happy with that method. I'm going to show it using the grid. With the grid, everything inside goes on the top and what's outside goes on the left. So 3 times 7 gives me 21. 3 times x gives me 3x. And it's a positive times a negative, so that stays as a negative. So our answer there will be 21 minus 3x. Don't switch it round, keep it in the order that it is. Okay? And there's your 2 marks. For factorising, what we're doing is we're doing the opposite. Instead of multiplying out brackets, we're putting things back into brackets. So we need something to go inside and we need a multiplier outside. So if we look at 6 and 9, we know that 3 goes into both of those. So 3 will be our multiplier. If I do 6f divided by 3, well, 3 goes into 6 twice. So that gives me 2f. And 9 divided by 3, we know it goes in 3 times. And it's a positive divided by a positive. So that gives us plus 3. Okay? So just mix it up slightly, but it makes more sense if I explain that before we do the factorising. Okay? So, question 7. We're on to some time. So Annette and Pete are travelling to London. They're going to leave at 10:45 a.m. and she takes 4¼ hours to travel to London. And they want to know what time. So we're going to use a timeline. Okay. and they're leaving at 10:45, so I'll do 10, 11, and then so on. I might have overdone my timeline a bit there, but you'll get the idea. Now the common mistake, so we're going to leave at 10:45. The common mistake is here, the quarter. Now if we remember our decimals, fractions, decimals, percentages, we know 1/4 is the same as 25% and the same as 0.25. So people think, 4¼ hours, it must be 4 hours 25 minutes, and it's not right, okay? So let's get rid of that. Do not do that. The reason being, because it's 1/4 of an hour, and that's out of 60 minutes. So half an hour would be 30 minutes, 1/4 will be 15. So this, we've actually got 4 hours and 15 minutes, okay? So to go from 10:45 to 11, that's our 15 minutes. And then we've got, so that's used, we've got 4 hours. So we've got 1, 2, 3, 4, okay? And that's 4 lots of 1 hour. 1, 2, okay? These bits at the top you don't need to show. I'm just doing that for the explanation. So we arrive at this time, okay? And I've done it in 24 hours, so we would arrive at 1500, but you might have done it in 12 hour, which would make it 3 p.m, okay? Doesn't matter which one you do, marks are there for both, okay? So then, Pete has a target of 3 hours 40 minutes to travel from Nantwich to London, and he's been driving for 117 minutes, okay? Now the temptation is to change that into hours and minutes to match that, okay? And it would be 1 hour and 57 minutes, okay? But they want the answer in minutes, okay? How many minutes longer does he have left to drive? So while you can gain a mark for that, I wouldn't do it, okay? I'd change this into minutes. 3 hours, now an hour we know is 60 minutes. So we can do 60 times 3, and that will give us 180 minutes. We can add our 180 to the 40, which gives us, so we're going to have a bit of a carry there, so we get 220 minutes. And now we can do our 220 minutes, take away our 117. Now we can't take 7 from 0, so we have to borrow. That becomes a 10. 7 from 10 leaves us with 3. 1 from 1 is 0, and 1 from 2 is 1. So we've got 103 minutes. Put in the correct unit and we're good for that. Okay. So that was our time. So then we can deal with question 8. And we're getting ahead of myself. I'm nearly going for the graph when I need to do question 8 first. Okay. So Nicola uses a tally chart to record the flavours of sweets in a bag, and these are the line tallies that we've done, okay? And each 5-bar gate represents 5 sweets. We've seen these before. So we've got the information there, but we don't have the totals at the minute. Nicola says the number of orange sweets is more than the total of the other sweets, because orange have 3 5-bar gates, 1, 2, 3, while the others only have 2 5-bar gates, 1 there and 1 there. And they want to know, is she correct? And while there are more 5-bar gates for these than there are for the others, we need the totals, okay? So here we've got 5, 10, 15, so we've got 17 there. We've got 5, 1, 2, 3, so we've got 8, 3 there, and 5 plus 4, it gives us 9, okay? So what we're going to do, going to add up the totals for the other 3 and compare it to that, okay? So we've got 8 plus 3 plus 9, which gives us 20. And we know that 20 is greater than 17. So is Nicola correct? No, she isn't. There are more of the other sweets put together than there are for the orange. Okay. Now I've used the symbol there, more than or less than, as we're used to. If you're not confident in that, just write it as 20 is more than, or 20 is greater than 17. It still gets the point across. Okay. Now, the bar chart. It says on the grid, draw a bar chart to represent the data in the tally chart. So we need to put that in, okay? And that's all we're going to do. We're going to use those frequencies to represent our bar charts. So first things first, we know the orange was 17, so halfway between the 16 and 17, and I can draw that in. The line was only 8, so nice and on the line for that one, 8. So we've got that there. We've only got 3 for the next one, so that's what we do for that. And the last one is 9, so again halfway between the 8 and the 10, and we've got that there. Okay. Looks good so far, but don't forget we have to label. So I'm going to be, because it's down to the sweets, I'm going to put orange, lime, strawberry and blackcurrant, and I'm just going to put flavour there. They haven't asked for it, but it's best, I'd rather see it and not need it. Okay, so what we need, when we look at our mark scheme, it says for fully correct bar chart, the bars are axis labelled with types of vehicle. It says vehicle when it should be sweets, even they get it wrong. And we can do O, L, S and B, it can be shorthand. Equal gaps or no gaps, and we can see there the bars are the same width and the gaps between are the same. I could have easily done double width bars with no gaps, that would have been fine. And of course all heights correct for their frequencies, which we are correct on that one. Okay, so that will be 3 marks, nice and easily done. Okay, so then we've got probability, and it's probability notation, and they're asking what this means. And we've got a funny symbol there we may not have seen, and it's the probability of A intersect B. Okay, and just to show you, we've got that on there. So A intersect B is A and B together. That's centerpiece. So it's not the A union B, that's the other way around, and that would be all of A and all of B. For A intersect B, we just want what appears in A and B, so that's centerpiece. Okay, so that one would be A and B. Okay, so we are going to go through these in the classroom. I'll get you to copy those into the books as well as a reminder. It's the type of question that relies on you knowing the information rather than actually calculating anything. Okay. So I'm going to hold there for a moment as we go on to question 10. And as we go on to question 10, we've got perimeter. Perimeter is all the way around the shape, okay? Or add all sides. So all the sides added up would give us 180 millimeters. And the other word that's important is regular. A regular hexagon means same length sides, same angles, okay? So the first thing I want to do is I'm going to take that 180 and I'm going to divide it by the 6 sides. So we know 6 doesn't go into 1, so we carry it. 6 goes into 18, goes in 3 times. So that means that each side is 30 millimeters, okay? And we're going to make this new shape by joining a square to the hexagon. And we can see there's no overlap, so the sides of the square are the same. And the mistake people make here is they count those sides. They think, well, that's already 180, so I'll do 4 lots of 30 and add it on. But those 2 sides are not part, where they join, they are not part of the perimeter. What we have got, we've got 1, 2, 3, 4, 5, 6, 7, 8 sides, okay? So that means I need to take my 30 for each side and I need to times it by 8, okay? So 30 times 8. 8 times 0 gives us 0. 8 times 3 is 24. So we carry that. So we've got an answer of 240 millimeters. Okay, 240. and that's all it is. All right, just be careful, as I say, with those. The perimeter is just the outside, not what goes on the inside. So, now we're dealing with money. We should all be able to deal with money, I would hope, and it's hourly rate. So this is important to us. So last week Emily worked for 9 hours. She paid no tax and received £72. So obviously the wages was below the tax threshold. And this week she's going to work for 12 hours and she assumes she's going to be paid at the same rate and pay no tax. So we need to know how much she's paid per hour. Okay? And to do that, we take our 72 and we need to see how many 9s go in. So I can do 72 divided by 9. If you're happy with that, great. Otherwise, my advice is do a quick 9 times table. And each time you go up, add 10, take away 1. So we'll have 9, 18, 27, 36, 45, 54, 63, and there's our 72. So it goes 1, 2, 3, 4, 5, 6, 7, 8 times. So that means we're getting £8 per hour. Okay? And she's going to do that for 12 hours. Now, a couple of different ways we can do this. So I'm going to do 12 times 8. 12 hours times the £8 per hour. 8 times 2 gives me 16, carry the 1. 8 times 1 gives me 8, plus the 1 is 96. So that means we've got £96 pay. Now we know that 9 hours was 72, so we could have just done the 3 additional hours. 3 times 8 gives us 24. Add to that, we will get the 96. Okay. Now, we're not going to worry about that for now because we've got part B. And I'm just going to make a note here at the top. £96, okay? Because that was how much she estimated she'd get paid, the assumption. But in fact, she is going to get an extra 50 pence per hour and she's going to pay £5.70 in tax, okay? It comes in with one hand, goes out with the other. And we need to find out whether the amount she earns is less than, the same, or more than she expected. And this one, we have to show working to support the answer. If we tick a box with no working, we will not get the marks. Now we could do, she's going to be earning £8.50 an hour, we could do £8.50 times 12 and then take that away. But we already know what the expectation was. She's getting an extra 12 hours at 50 pence, okay? So 12 hours times 0.5 will give us £6 more. And we're paying £5.70 tax. So £6 is more than £5.70. What it means is she is better off, only by 30 pence, but it's definitely better in our pocket than theirs, isn't it? So it is more than she expected. Okay, we can tick that correct box. So that's question 11. On to 12. And it's all to do with averages, which we have done recently. So complete the list of 6 numbers so that the mode is 10, the median is 12, and the range is 9. Okay? So I'm going to deal with it. I can do it piece by piece. Doesn't matter which order we go. Okay? I'm going to deal with that first. I'm going to say the mode is 10. The mode is the most common, so I'm going to put an extra 10 in there. So that appears more often. I'll deal with the median. We need the middle. Now there's 6 numbers. So that means that these 2 added together and then halved would give us 12. Okay? Now one thing, you might think, well, I can put 12 and 12 there. But if I do that, there'd be 2 12s and 2 10s. They would both be the mode, not just that. So I can't put 2 12s there, but what I can do is I can go 1 less and 1 above. So that means the middle is 12. So we've done the mode, we've got the median, and the range is 9. The range is the highest, take away the lowest. So that's my lowest, so my range needs to be 9 more than that. So I can put 19 there, okay? They don't have to be those exact numbers. There are different ways of doing it. But generally, I would, because we're dealing with range as well as the median, I would do them in ascending order, just to make sure we're okay. And then we're on to shape. So this shape has an odd number of sides. It has more sides than a triangle, which has 3, and fewer sides than a hexagon, which has 6. So we're looking for an odd number between 3 and 6, which would be 5 sides. A 5-sided shape is a pentagon. Okay, so just a bit of deduction there for that. Now, question 14. If you hate these, we are going to be going through them in the next few weeks. Okay. It says, on the grid, draw the graph of y equals 4 minus 2x for values of x from minus 2 to 5. Now that's enough to switch most people off. Okay. So what I'm going to do is I'm going to do a slightly different table this time. We've got x and y. Okay. I'm going to show it vertically because it means I can show it a bit bigger than if I tried to squeeze it in there. The values of x from minus 2 to 5. So minus 2, minus 1, 0, 1, 2, 3, 4, 5. Now that sounds like a lot of work. But promise you we can do it a lot easier. Okay. So we're going to start at 0 if x is 0, because what it's telling us is y is equal to 4, take away 2 lots of x. So if x is 0, 2 lots of 0 is 0, 4 take away 0 leaves us with 4. Okay. If x is 1, 2 lots of 1 is 2, 4 take away 2 leaves us with 2. If x is 2, 2 lots of 2 is 4, 4 take away 4 leaves us with 0. Okay. Now I've done 3, and I haven't touched the negatives yet. But notice the pattern. We're going down by 2 each time. And that's our gradient. It's there, minus 2. So that means I don't have to actually calculate anymore. I know I'm going down by 2 each time. So minus 2, minus 4, and minus 6. And that means going back up, I'm going to be adding 2. So we're going to end up with 6 and 8. Okay? So now I can plot my graph using these coordinates. So if x is negative 2, y is 8. I'm going to put a nice big X there so they can see what I've done. Next one is minus 1, 6. 0, 4. We've got 1, 2. We've got 2, 0. And you can see already it's going to be a straight line, isn't it? So let's carry on. So we've now got 3 should be minus 2. 4 was minus 4. And 5 would be minus 6. Okay, and we can see that there. So we've got 1 mark for getting the coordinates, we've got 1 mark for plotting the coordinates correctly, and that leaves us the last mark, which is this. Okay, now it says from negative 2 to 5, so you only need to draw that line, but if you were to draw it all the way across the graph like so, you wouldn't lose any marks. Okay, it's in the mark scheme, it's allowed, so we're okay with that one. All right, so that's our graph. So question 15, our old friend the fractions. Okay, and no one really likes these, but it's knowing the process. I'm going to write them out bigger so we can see more clearly. 7 tenths plus 13 15ths. Now we can't add them because these two numbers are different. Okay. Now what we could do, we could times them by each other. So that would mean our answer would be over 150. Okay. I'll come back to that in a moment. Okay. I want to try and keep my numbers small. Now 10 and 15 are both in the 5 times table. So we just find a common multiple, the lowest common multiple for those. So what I can do, if I times this one by 3, I'll get 30. And if I times this one by 2, I'll get 30. Okay. Good so far? So I do the same here. 7 times 3, and that gives me 21, and 13 times 2 gives me 26. Now, once the bottom number is the same, it stays the same, and we add those two together. So 21 and 26 gives me 47. I've got 2 marks now, one for the conversion, equivalent fractions, and one for this answer. But they want it as a mixed number, combination of whole numbers and fractions, okay? So I would need to see, well, we know 30 goes in there, and it's only going to go in once, because 2 lots of 30 will be 60. So what I can do is I can do 47, take 30, and that's going to leave me with 17. So because it goes in once, that's my one whole number, and that's my remainder, 17. I've got 17 over 30. So 1 and 17 over 30. If you did it the other way, what you would end up with is 235 over 150, which simplifies down to 185 over 150, which does actually simplify back to that. But again, on a non-calculated paper, we'd rather keep our numbers smaller. Okay, so that was 15. On to 16, and we've got triangle on a grid. It's reflected, so it's a mirror image, and it's reflected in a vertical line, so we're going to have a mirror line somewhere on this page, okay? And they've given us 2 of the corners. They said vertices, vertices are corners. So we've got 8, 3, so come across to 8 and up to 3, and 8, 7, so 8 and up to 7. So there's my first straight line, and because it's a mirror image, I know that triangle is going to flop over, so it's going to face the other way, and this bottom face is 3 along, so I can go to there. Now I'm going to draw the triangle in. I don't need to, because that's what we're interested in. The coordinates for that are 11, 3. So we do 11, 3. Okay. And when it says what is the equation of the line of reflection, they want to know where that mirror line was. Okay, so as I move that across, I can see that my mirror line would be exactly halfway between 6 and 7. Admittedly, my drawing isn't exactly halfway, but it should be. So we should have 1.5 squares either side. So this would be 6.5. And because it's a straight line up from the x-axis, that means the answer is the line x equals 6.5. Because every point on that line, the x-coordinate would be 6.5. Here it would be 6.50. Here it would be 6.54 or 6.57. So that's where that line is x equals 6.5. Okay. So on to question 17. Now these, we've got 2 lots of fractions thrown in, and they're asking for the answer as a fraction. That's enough to switch anybody off. So let's break it down. We're going to start off with 60 necklaces, and she's going to take 4/5 of the necklaces to market. So to find a fraction of an amount, we divide by the bottom, we multiply by the top. So 60 divided by 5, 5 goes into 6 once with 1 remainder, and it goes into 10 twice. So that's 1/5. So then we take our 12 and we multiply it by the 4. Okay. So 4 times 2 is 8, and 4 times 1 is 4. So we're going to take 48 to the market. Okay. So the next line is, at the market she sells 2/3 of these necklaces. So again, we're going to take that 48, we're going to divide it by 3, and we're going to times it by 2. So 48 divided by 3, 3 goes into 4 once with 1 remainder, and it goes into there 6 times. Okay, and 16 times 2. So we're going to get 12 there, 2 plus the 1. So we've sold 32 necklaces. Okay. So the next line is, what fraction of the necklaces does she have left? We've sold 32. So 60, take away 32, and borrow. So that's going to leave me with 8, 3 from 5. So she's left with 28. And that is 28 out of 60 necklaces. Okay? So we had 1 mark for there, 1 for there, and we've got 1 there. So we've one last mark to get, and it's there, the simplest form. So they're both even, so we can halve them. So I've got 14 over 30, still even, so I can halve them again, and I've got 7 over 15. And that is my answer. Okay, can't go any lower than that. And then we're on to the last question, which looks utterly horrible. Okay. So what we're going to do is deal with what we can do. It looks horrible, but let's deal with what's in the brackets first. True BidMaths fashion. 3 squared is 9. So our brackets, we've got 9 plus 1, which is going to give us 10. Okay. 5 outside of the bracket means we're going to multiply what's inside by 5. So 5 times 10 gives us 50. So we've done with that side, haven't we? We've now got 86 minus 50. And that leaves us with 36. And the bracket is the square root. So we want the square root of 36. So we're looking for what multiplied by itself gives us that. And 6 times 6 gives us 36. So the square root of 36 is 6. And that's it, done. And you might look at a question like that and think, nope, don't want to know. But just doing something as simple, when we check the mark scheme, just doing something as simple as doing the 3 squared plus 1 to give us 10 gets us the first mark. Okay? Anything, any of those processes will get you the first mark. And then do a second stage, gets you the second, and obviously the answer to gives you all 3 marks. But we're worried about making sure that we can make a start. If we can make a start, we'll gain marks. And gaining marks is the key to improving our grade. Okay? So trying questions like this and questions like that will make a big difference to us. Okay? So hopefully you did okay on this one. Remember, it's only a signpost on the way towards the exams. And we'll do another one in probably about February. And we'll see how much we've improved for that one. Okay? See you later.